So the model that we need to select now in the dropdown is going to be that Claude Sonnet 1 million. I don't know about you, but I feel like a millionaire just selecting this model on the dropdown. It's like, yo, we're about to start dancing. This is crazy. I didn't realize it would go that long. Claude Sonnet 4 with 1 million token context window is now officially supported inside of Cursor, and this workflow is incredibly fast. And I'm really excited to show you because we're about to be dealing with a million. That's right, 1 million token context window. We gotta crash. What's going to be really fun here is if I throw the entire kitchen sink, will Cursor and Claude Sonnet be able to think through all these different things and then chunk out my plan and kind of keep going with it. So this is going to be our test here, and we're going to see what happens and how many tokens it generates with the first step there. What does this actually look like when you're using it inside Cursor? So there's two models that are currently available. I'm going to enable both of them. One of them is without thinking, and the other one has a little brain there, and that means thinking. The thinking model from Claude Sonnet outperforms the Opus 4 model without thinking. And so if we're getting this really high level of intelligence with a large context window with 1 million tokens, we're going to have like the most premier experience ever here. I'm going to kick off this massive plan that I had generated using Claude Opus. So yes, I use Claude Opus as well. I use any model that's going to help me get the most intelligence from my apps and my performance. And so what this plan is going to go ahead and do is going to basically insert an editor into our app so that we can go ahead and start cooking with this. Let's go ahead and start with the implementation for this plan. So now that we hit go, we're letting Cursor basically start doing its cooking. It's fine dining, fine mining. And I've actually implemented the plan in phases so that AI agents can take these chunks in phases and implement them. And so that's like the cheat code if you don't know. And so the cheat code is to tell it whenever you're generating your big plans, is to just do it in phases so that the AI agent can go step by step. And we're just going to see Cursor just fly through this entire thing much faster than it would if it was using Claude Code. And because we have the million token context window, we can actually start monitoring down below by hovering your mouse over this little icon down below. See this little thing, it says 7.9%. We can see the context window being updated in real time. So that's grabbing files, that's grabbing everything that it does in the context to build that its requests, and including the code output and other things. And now it's just flying through step by step. So it made its own internal to-dos. As you can kind of see there in Cursor, it's installed the packages using Bun, which is my preferred package manager, and it's reading through that. So if we click this here, it says there's 2 of 5 to-dos here. Phase 1 is to install the required packages. Then it's going to create a transcript editor, and then it's going to implement the viewer and the components. So the specific instructions, I said, make sure you chunk out this plan into multiple steps so that an engineer or an AI agent can take this plan and start implementing them and verify at each single phase that we've implemented it correctly. It arranged all of the actual implementation details by verifiable steps so that basically that's what Claude Code is doing. That's what all these tools are doing with agents. As soon as they implement the code, they have a verifiable step before they do the next tool call. And they're also doing extended thinking on that too. So they try to look back into their history and see what they've done here. So as we're seeing just in this like one prompt, it's still cooking, by the way. It's literally still cooking, and we've only used 103,000 tokens. That's 10% of the 1 million token context window, and we're still flying, ladies and gentlemen. This is crazy, and it's happening right here in Cursor. This may actually be done with implementing the features. It just went ahead and implemented phase 2. Oh my goodness. So I have no clue if this is even going to work, how it looks like. We've just totally just YOLO'd this whole thing. This is amazing. This is so amazing. Wow, we're really just flying with this whole implementation. This is a massive feature, by the way, just to I've put it off implementing this feature because I knew it was just going to be super massive, but now I'm super confident with this 1 million token context window for 1, debugging, 2, looking through code like this at this massive window and this overhead. It just kind of gives me a lot more breathing room. So I can edit the transcript now. So I'll show you what this looks like normally in production. So app.radon.transcribes. So for those who don't know, if I go to a previous transcription, I could see my whole live stream, but I can't edit this file. I have to download the text files and then use my own text editor to do that. So this is basically now the one that's currently on localhost. This is what it basically one-shotted in one whole thing. So if we go to edit transcript, we're going to go into this edit mode. Oh, we got to crash. We got to crash. What do we do? 911? 911, we got to crash. Oh, the database is freaking out. It's freaking out hard. I don't know why. Let's see. The app crashes right after 1 second. And it looks like there's an error on the convex side. So I'll need to have you dig in here. And so one of the things that I can do is maybe duplicate this chat so that I can do some debugging. So I'll keep the context of the entire implementation. I'm thinking in the old paradigm of I only have 200,000 token context window, right? So in the old paradigm, since I've already used like 200,000 tokens, I have to clear out the chat. But today we have a 1 million token context window on literally the best coding model in the world out today. And so what if we duplicate this chat and then continue the debugging there? Because we still have like 90% plus of the context window available for us. Even if we do hit that 500,000 token context window, I'm pretty confident we should still be able to cook. So now we're in the duplicated chat, and this has a little thing up here, and then it has all this context from all of our other chats, and we still have this thing that's used up. I need you to dig in here. And so I'm just gonna let the agent do its thing. And so it's doing its thing. I'm gonna go ahead and just hit stage to stage all of the commits. So that way I don't lose anything. So just that way I can see all the diffs and see what it's actually fixing / changing. By the way, there's more phases to my plan and it's currently not yet implemented. I totally forgot about this. So this is only phase 1 and 2. It's possible that we have not continued to implement the rest of the phases of the plan. And that's probably why it's freaking out, right? I think we've only done either 1, 2, or 3. There's like many more phases. And so I told it to make sure that we can stop and kind of review the changes as we go. And here are the main issues: the invalid ID, when it becomes the premature autosave, the incorrect, let me fix this issue. So I think I might just reject it and say, I forgot that I'm only partially through the plan. Is the implementation in the rest of the plan, or do we need to fix this bug now? I think that's kind of where we need to understand where we're at. So now it's gonna just re-review the plan, and it's gonna look through all the phases. It's actually, you can see it in the stinking windows. It's like doing the check mark thing. And so far we've only used 14.9 or 149,000 tokens. So not implemented are phases 3 through 5. So there's still 60% of my plan that's still not been implemented and the immediate issue to fix. So the app crashes when clicking the edit. This is blocking further development and needs to be fixed first. So the root cause is the autosave hook is receiving an invalid ID, empty string when the model mode starts. So this is the fix and this is the recommendation. And I think this is a really good bug fix, especially at the phase that we're in developing our features. And we should actually have like a minimum testable feature, especially after this implementation. Yes, let's go ahead and fix the crash bug, because now it's come to the point where if I view any transcript, it just keeps crashing out. And so now it's going to fix that bug, and let's just go ahead and see what it did. Okay, so now it's passing in the string or null. Okay, that makes sense. And what else is it doing here? If not enabled, autosave is disabled. Okay, so it's kind of accounting for a state and then invalid IDs. Okay. Let me go ahead and say accept. Now it should have fixed everything. So let's kind of see bunx convex dev. Let's go, fam. So now this is crazy. This is absolutely bonkers. I mean, this is a massive feature and we're crashing probably. Yeah, we're still crashing. What I can tell it to do is take a look at the convex dev logs and see if we can kind of pull that up. Can you use the convex MCP in the dev environment to take a look at the recent logs here? Awesome. It's doing this MCP tool calls. And so these were the fixes that it did about the invalid job ID. And it's going to take a look at some of the errors and we'll see that. So far, how much have you used for the max cost? So we've used 84%. Holy smokes. That's a lot of files. Man, it just like blew up. Wow. Prompt is too long. Please shorten the prompt. Copy request info. This is crazy. I didn't realize it would go that long. I wonder why. Oh, because of all this other iteration with the code. Wow. I didn't really catch that. I was just kind of flying. Holy smokes. So now it's basically trying to summarize a chat. See, it's already doing that for you. So as of now, theoretically, if I already used 1 million token context window, I already pushed above the 200K token context window, and we just ate up like 500K, probably right around here, something like that. Oh, you know why? I think because of the MCP tool call, because I don't know if you know this, for the tool call, see, this is what ate it up. This transcript is a 4-hour live stream. Of course, I chose a 4-hour live stream, and in the tool call, it fed that entire live stream transcript and all this other data into the tool call, which is over like, look at this. I'm still going, by the way. It ate up all of my context. So that's a really good heads up. If your MCP tools, so this is something we learned today. If you have an MCP that does a tool call on your database, and whatever stored in the database has a lot of files like what I have currently, it's like this really large 4-hour live stream with timestamps and all this data, it's gonna eat up that context window. And we're seeing that happen first time. We went from 100,000 token context window to almost eating up the whole million just in one prompt, because it went through this entire, it did an MCP tool call, and the tool call literally ate my whole thing. That's so sad. For me, that's kind of what I was a little bit afraid of, is I was going to eat this whole thing. And so what I think could be easier is if I just go to my Convex dashboard and take a look at the logs there and just kind of copy and paste what the logs are saying. That way we won't have like the entire transcript that's in here as far as like what could be going wrong. If you were kind of wondering on the cost, I was still at the under 200,000 token context. So I only popped into here because of that mistake with the MCP, and it just like ate up all my context. But this is what we're looking at for the input and for the output. So this whole thing would have probably cost me, you know, like $30 or something for that request. So yeah, over 200,000 tokens, the input's going to be $6 instead of $3, and the output's going to be $22 instead of $15. What I'm going to go ahead and do is just kind of restart this request, and you can see we're back down to 170,000 token context. So I went back into the chat, and that's what's nice about Cursor is it'll trim everything out that happened. If you go back to that chat, everything below, it's just going to go away. So that's really nice because I don't want that rot back into my context. That whole conversation ate up like 800K tokens from that tool call, just that one tool call. That's what I don't want. So I'm really curious to see what happens when I do this type of thing here and I try to load it up in here. So let's see if I can run it, because I want to run it and see if it can capture that error for us. It might freak out. So we'll see. Is it going to? Yeah, it freaks out. So it should catch it here. But I'm wondering if it's just going to eat the context window. And if it does, we're cooked, fam. We're so cooked. Oh, I think that's what it is. You have to run bun x convex dev. Looking at this, it says suggest the data structure is being returned from the query doesn't match. I see the issue. The validation error gets stuck here. And cool. Awesome. We still haven't even eaten up that much of the context window. We haven't even crossed the 200,000 mark yet. So we're still playing the regular Claude Sonnet 4 prices. And theoretically, we should be Gucci, fam. So let's see. Okay, so we have the transcript. We have this thing here. This is a massive transcript, by the way. We're going to edit. GPT. Okay. Oh, the performance is horrible. Bro. Okay, so I don't know if you can't really see it on the screen, but basically my mouse is like doing the little spinny wheel of death. What we've done so far, we've been able to use 1 million token context window to basically get like the first 2 phases of our massive feature plan implemented. So that was like installing all these files, doing all this work all over across the board. You saw how fast Cursor was at going through the plan, iterating us, and then getting us to that first kind of landing part of the page. We got to play a little bit with the UI, but then when I gave it something that basically you saw, it has like 800,000 tokens. That transcript is so long. It's like a 4 or 5 hour live stream. It transcribed it, right? But that transcript's so big that when I'm actually working with this feature, I need to fix this bug so that other people don't have that issue. I used to be an engineer at Apple, so I'm very familiar with debugging like on-device memory stuff and like figuring out these cool memory problems. I've never really done it for the web, so this is going to be a really fun endeavor. I'm going to figure out what dev tools we can use, what type of things we can monitor for performance, and understand like how is the memory being allocated? How is it loading the entire like, you know, 800,000 token context actual transcript in memory in the browser? I mean, that's probably what's causing it to crash, right? There should be other methodologies to help us along here, and I'm really confident that Claude Sonnet with the 1 million token context window could possibly be getting us there.